Welcome to the HPC Best Practices webinar series. The series is brought to you by the IDEAS Productivity Project, which is part of the Exascale Computing Project of the United States Department of Energy. I'm Osni Marquez from Lawrence Berkeley National Lab, and I'll be the host for today's webinar, A Cast of Thousands, How the IDEAS Productivity Project has advanced software productivity and sustainability. The webinar will be presented by David Bernhold. David is a distinguished research and development staff member in the Computer Science Mathematics Division at Oak Ridge National Laboratory. His research interests are in making it easier and more productive to develop and use scientific software, particularly on high-performance computers. David began his scientific career as a computational scientist before transitioning to a focus on computer science topics. And he has worked in computational science and engineering projects in various domains throughout his career. David has leadership roles in multiple projects in the Exascale Computing Project and the Scientific Discovery through Advanced Computing SciDAC program at the Department of Energy as well. He leads the program environment and tools area for OLCF, the Oak Ridge Leadership Computing Facility. We have issued more than 100 tickets for today's webinar, and all attendees have been muted upon entry. We'll receive questions through the Zoom chat and also Google Doc, whose address I'll paste in the chat momentarily. And David, please stop my sharing here.
Thanks very much for that introduction, Osni. And thank you all for attending. Just trying to arrange my screen. So I'm very happy and honored today to be able to represent the IDEAS-ECP team to tell you something about the work sort of behind the scenes of this webinar series and perhaps behind the scenes of other things that you may be a little bit familiar with. If you're interested, I've put links to various resources throughout this presentation. So if when you get a copy of the slides, there's things you want to follow up on, that would be an easy way to do it. But I'll just point out also that we have the ideasproductivity.org website, and we also have a link there to a preprint of a paper we just submitted to a special issue of Computing and Science and Engineering that will be one of the several special issues that's being organized to sort of memorialize some of the interesting things that the Exascale Computing Project has done. So I want to start with a little bit of a history of the IDEAS Productivity Project. IDEAS actually stands for Interoperable Design of Extreme Scale Application Software, although as with many acronyms, we don't end up expanding it too often, and we've kind of, in some ways, outgrown the actual words of the acronym. But really the importance to me of IDEAS is that back when it started in 2014, it was the first of its kind project, certainly in the US, with a focus on incubating, curating, and disseminating knowledge and methodologies about the sustainment of scientific software. So this is not a project that's been focused on software engineering research or things like that. It's really been focused on helping scientific software projects do a better job with their software. And a lot of the inspiration for the IDEAS concept came from the United Kingdom Software Sustainability Institute, which has been around for a long time. So I just wanted to make sure to give a shout out to them. They've been very inspirational all along the way, and we have good relationships with people there over the years. IDEAS is now a family of related projects, which have had different sponsors and have happened in different timeframes, and have had different people involved in them, although there's been significant overlap. And we're taking different approaches to this general problem, but we all have a focus on improving developer productivity, software sustainability, and trustworthiness. And so IDEAS started back in 2014 with a project that was jointly sponsored by the part of DOE that supports computing, which we call OSCAR, and the Office of Biological and Environmental Research. And the purpose here was to support a team of terrestrial ecosystem modeling projects within the BER domain, and they wanted some help from the computing folks on the OSCAR side to do this. So this started this project that we now call IDEAS Classic. It was the first one in the series, and that ran from 2014 to 2017. And then that project ended and the ECP, Exascale Computing Project, was starting up. And in 2017, IDEAS was added in a different form that we'll talk about to the ECP. And that's running through December 31st of 2023. And the focus here has been on supporting the ecosystem of software that's been developed by the ECP, not surprisingly. And then another project called IDEAS Watershed started in 2019. That's in some ways a continuation of the IDEAS Classic project. This time it's sponsored only by BER. Focus is a little bit different than the original IDEAS Classic. It's on accelerating watershed science, but a lot of similar principles are involved. And so this is the sort of the history in one slide of the IDEAS family of projects. And of course, today I want to talk mainly about the IDEAS-ECP project. And so in order to do that, I need to spend a few minutes talking about ECP itself. Many of you on this call are probably at least aware of it or heard of it, but I just want to make sure we're all on the same page. So the Exascale Computing Project was developed, started back in 2016, kind of as a companion to the procurements of exascale systems that several of the DOE computing facilities were undertaking. And the purpose of the ECP was to deliver a stack of software and applications that were ready to run on these exascale systems when they hit the floor. And so there are several key parts of the Exascale Computing Project that I'll refer to. One is application development, another is software technology, and then hardware and integration. It doesn't actually have so much of a role in the software space, but that's actually where IDEAS lives and some other things. Also, the training aspect of ECP lives under HI. But to dive a little deeper, looking at the applications, there are a total of 24 applications plus 6 co-design projects, which are primarily producing libraries as opposed to applications. A total of 62 separate software products comprising this whole space. And the applications span a very broad range of categories and different scientific domains. I'm not going to go into the details here. There's plenty of information available about these projects if you want to learn more. And then the software technologies side of ECP was meant to provide the software infrastructure, the tools and compilers and libraries that the applications need to succeed. And so this comprises 35 projects and 70 software products that are broken down as you see on this slide: programming models, development tools, math libraries, etc. And so you can see, and each of these projects has a team of people that's working on it, producing software. And so you can see it's a very active kind of thing. And in total, there's around 1,000 people who've been involved in the Exascale Computing Project. So when we were asked to construct a version of IDEAS to support the Exascale Computing Project, we realized right away that it had to be different. This is, ECP is very different from what we were trying to do in IDEAS Classic. It had a very stringent set of deliverables focused on performance and capability, needed to be able to utilize the new exascale hardware platforms, but at the same time, that hardware was only going to actually be available late in the project. So there was a long lead up where projects were needed to be doing exploratory work. They're going to be working with tool chains that had lots of problems or inadequacies in them, be doing extensive experimentation. So this is really going to be a time where the software development teams needed to be as productive as they could in the face of all these challenges and all this change was happening to them. And as I said, with 1,000 people, there was no way that we could do the one-on-one interactions that we had tried to do in the IDEAS Classic project. So we formulated a different approach for IDEAS ECP, focused broadly on 3 areas: fostering software communities, developing broadly applicable methodologies and resources, and also disseminating knowledge. And it's important to recognize that while we were supporting the ECP scientific software community, as you can see over here on the right, Almost everything that we did was designed to be able to support a larger group of a larger community, right? So we're interested in ideas and practices that could be taken out to the larger DOE scientific software community, and even the general scientific software community. And that especially goes to the dissemination of knowledge that we developed. And I'll talk about these things in the coming minutes. But right now, this is a good place to stop and see if there are any questions, particularly about the Exascale Computing Project, before we move forward.
David, I don't see any questions here.
All right. So as I said, we designed our work in these various areas, and I'm not going to read everything on this slide, but I'm going to go into details in each of these areas in what follows. So first, in terms of fostering software communities. So as I said, this is the ECP in particular is essentially a collection of projects under a much larger project umbrella. So a total of around 100 projects doing, some of them doing multiple software products as part of their work. And what we're looking for here is approaches that could help these teams do better and faster, so accelerate the design space exploration that they needed to do, help them advance the quality and usability and interoperability and sustainability of their software products while respecting the autonomy of the teams. And one of the vehicles that we found that's very effective in helping make that kind of thing work effectively is community policies, which I'll go into a minute. In a minute, and we have this idea of software development kits, which are basically communities that have come together and set for themselves some policies that help establish this set of software products as working together in certain ways. And so I'll just throw out a few names here. There's XSDK, which I'll talk about a little more deeply. CAT SDK is a code analysis toolkit, which is a version control repository analysis. This is the ECP had a number of these. This is the data and visualization SDK, et cetera. And so I want to talk about the XSDK as sort of the most mature example we have in this space. The XSDK actually started during IDEAS Classic. When working with these terrestrial ecosystem modelers, one of the things that was really challenging for them was they would be trying to put together applications that were using multiple well-known math libraries, mostly developed from the DOE community, and they were having challenges because these libraries didn't work, they didn't play well together. And in fact, it was challenging in many cases, even to link together a single executable that had multiple of these libraries, because they would conflict in different ways. So we developed this concept of an extreme scale software development kit to bring the libraries together and get them to collaborate on ways that would ensure they could work together to support the needs of these terrestrial ecosystem modelers. And in the first release, we had these libraries, Hyper, Petsy and Tau, SuperLU, and Trilinos, together with Alchemia, which is a domain, BER domain library, and that comprised the first release of the SDK. And over the years, this has been spun off and it became an independent project within the ECP. And it has grown, as you see. So now, as of the November release last year, there are all these different libraries that are involved. pFlowTran, which is another domain library, was added in the second release, but we have now all these others. And we even have contributions from libraries outside DOE that have seen the value of this ecosystem that's been formed and have wanted to join. And I'll get into that a little more to explain that a little better in a moment, but I just want to note here that we have, if you're interested in more detail about this, we have, there's an article in SciAm News, which is a link here, and we had a webinar a while back on this from these folks, Ulrike Meyer and Satish Pillai, who have been leading this work in the ECP. And so here's what XSDK and other software development communities do that really makes a difference. They've set a set of policies that all the participants in the community have agreed to conform to. And these are things that are identified, they're specific to the community and the needs of that community. And so they'll vary from one community to another. This is just an example of what the latest version of the XSDK community policies. And you can see there's a variety of different things here to help these packages work together. First of all, now they're expected all to be built and installed through SPAC. They're expected to have a test suite. They must have their own communicator in MPI, not use ComWorld. They must not pollute namespaces. So there's a variety of things. There must be a debug option in the build options. A variety of things that you can imagine, if you look at this list, will help these packages work together and not conflict with each other. And so this has been very successful, as you see by the number of projects that have joined this community. And so this work continues. And then another community that I wanted to point out, which has grown out of the Exascale Computing Project, is the Extreme Scale Scientific Software Stack, known as E4S. And this is a curated collection of software that's based around the ECP software technologies software products. As of the last release, there's 115 packages included here. And these have been they're curated, as I say, to work together and to build together and run together. And they have a different set of policies which they've used to help achieve this. And so they also require a spec-based build and install. They require some basic testing, but here they also require some documentation, and they require some metadata about the software product. And they have rules about if you're importing software packages, there are rules about how you can interact with those, right? You have to be able to substitute your own version for the version that they would build with by default, and these various things, right? So this is a different set of policies for a different set of communities, but the same basic concept that has helped bring together this set of projects to produce something that is better than the individuals working on their own. And so this is another good spot. If there are any questions that have arisen, please let me know.
There is one here in the chat, David. Let me see here. Communicators may consume hardware resources. I wonder if number 3 should be must allow a user-provided communicator so communicators can be reused.
So you would have to look at the details of what that policy means, and I suggest you look at this document here. I don't remember off the top of my head what the rules are. There, somebody else on the call might be more engaged and might know that. But yes, that's certainly a consideration, and it's I've watched a few of these discussions take place, and I would say that this is a very thoughtful and very open community that's very open to discussion. So I'm pretty sure this would have come up as they were figuring out what they thought the policies should be.
Okay, thank you, David.
All right, so next I want to move on to some of our work with incubating and curating methodologies and resources. And there's a variety of things that IDEAS has done in this vein. I'm just going to hit on a couple of them today. And so the first one is this idea called PSIP, or Productivity and Sustainability Improvement Planning. This is a process for software process improvement, which is an important aspect of doing a better job with your software. And there's a couple of points here. So this is a methodology that was originally developed by Mike Haru at Sandia, and Elaine Rayborn, also at Sandia, put together a team that's taken this forward in IDEAS and expanded out in ways that I'll talk about in a minute. But I wanted to start by going through this PSIP workflow that's at the heart of things, because I think it's a really useful tool, and it's really, I think, pretty simple to explain. So you're a software developer and you're working as part of a team on some software project. And undoubtedly, you have some pain points in your software development processes, things that are not as good as they could be. And so you decide as a team that you want to make some improvements. So you start by identifying the pain points in your software development processes. And one of the things we did was to develop a tool that might help you identify some of those pain points and things to work on. And then among those, you set a goal for something that you want to improve. You pick one thing. You want to target processes and behaviors, not just tasks. So it's not a matter of, okay, we need to add 40 more tests to our test suite. It's more a matter of, how do we ensure that every time somebody commits a new capability, they also commit a test to go with it, or appropriate set of tests to go with it. You should pick something that you can address in a modest amount of time so that you'll get a noticeable benefit, so that you're not just working and working and working and never seeing a return. And then you agree on a plan. So you identify, sort of the steps that you need to take to get this done, and you write down what to call done. Okay, when are you actually done with this little improvement process? You write these things down. We call these progress tracking cards. There's a library of these that people have created and used for various things that you're welcome to look at and take directly or use for inspiration. And then you, as a team, you work to your plan, you track your progress with the progress tracking card, check things off. And when you get down to the bottom of the progress tracking card, you're done, and you have a little celebration, and then you can pick a new pain point to address. And the idea here is that these are small incremental things, and you just keep doing them, and you can keep improving your processes. And the idea is basically, you have some way that you're working, which is envisioned in the red line here, and you want to bend the curve so that it takes less work to get to the same endpoint with the new process. And this might take an upfront investment, but you expect it to pay off over time. And we're not suggesting that you should just keep doing this ad nauseum, right? But there's a lot of things that most projects can improve. And what we recommend is targeting just enough software engineering in your project so that you can meet both your short-term and your longer-term scientific goals effectively. And for most projects, it's the longer-term goals that are really the long pole in the tent that motivate the continued investment in better software practices. And so Elaine and her team have taken this really pretty simple concept, and they've done some engagements with teams, particularly in ECP, but not exclusively. And we have a few stories to tell from that, but they've also expanded out to do tutorials to teach others about PSIP. They've been developing tools to automate some of the aspects of the PSIP process. And they've also been conducting research, which has been inspired by their experience with these PSIP activities with other projects, which I'll get to in a moment, based around team of teams concept. And so there are a variety of projects that have used or are using PSIP to improve their practices. I've highlighted just a few here on this slide. HDF Group, Flash 5, Exalt, and Alpine are all ECP projects, and you can see they've been doing different things so it's very tailored to each project's needs. We have some more general activities that are taking place at Oak Ridge and TU Darmstadt and Sandia National Laboratories, which are looking at the PSIP process from a little bit different perspective. But the experience here is that this is a really simple workflow that projects can implement to help them improve things, and they see a benefit pretty quickly. And here's a quote from Elena Permel, who led the HDF group in this PSIP activity right here. She said the PSIP project had an immediate impact on our community. With the GitHub move, we see increasing amounts of contributions to the HDF5 code and documentation. And there's links here for blog articles for these three PSIP activities if you want to learn more about those. And then Expanding on this, one of the things that I've mentioned about the ECP is that there are a large number of projects that interact in various ways. So what we really have in many respects might be called a team of teams. This is a concept that was popularized in Stanley McChrystal's book in 2015. He came out of the US Army, and this was about a lot of this originated with how the military handled things in Iraq. But it also has much broader applicability. And so the team of teams concept gives us a powerful lens through which to understand something like the ECP and a lot of other software ecosystem types of projects, and gives us tools to think about how we can improve the effectiveness of these organizations. We can use these concepts to strengthen partnerships. We can use this to scale the productivity. So typically, you find that smaller teams are more productive than larger teams just because coordination breaks down and things like that. And if you apply the team of teams concept, you can sort of break some of that so that a larger team is operating as a collection of smaller teams that interact in particular ways that are easier to understand, and you can use that to help scale up the work and the innovation and the productivity. And so these concepts have been, the PCIP team has been looking at these in a quantitative sense using the CAT SDK that I mentioned to understand software repositories associated with the Exascale Computing Project and understand different kinds of interactions and the people involved and things like that, to look at some of those principles. It's also been used, for example, with the HDF5 team to facilitate some of their contributions to the E4S software community and also to the Data and Viz SDK, which in turn has allowed them to better support some of the applications, a number of the applications activities in the ECP space. And so there have been a couple of other results from this particular team of teams investigation. We have a panel discussion series, and there was a panel discussion with members of the PETC, Trilinos, XSDK, and E4S projects about their perspectives and their experiences with the team of teams concept, and that led to a blog article. So we have links to both the panel discussion, which is archived like these webinars are, and then the blog article. And then there's also a journal paper, conference paper, I guess, published that's looking at a particular code, the ASC Ristra code, as another case study with a team of teams. And so these are, this is a significant area that IDEAS has been working on with the ECP. It's not the only area of methodologies that we've been developing, but this is some of the biggest story. But another thing that I wanted to make sure you're aware of, you may have heard of, is the Better Scientific Software site, bssw.io. This is obviously it's a separate website. It's a hub for sharing information on practices and techniques and experiences and tools that support your scientific software development. So what we wanted to do with this site was to provide a place that was focused on the needs of the scientific software community, as opposed to, there's lots of information out there about general software engineering practices and things like that, but they rarely consider the special aspects of the scientific computing environment. So some of them are more useful than others, and we wanted to provide a site that would help people in the scientific software community find resources that were more applicable to them, that others in the community had said, here, this has helped me, it might help you, to have experiences through these blog articles that we've talked about and other things. And we also use this site to share events that are relevant to the scientific software community, as opposed to the community that's focused on the scientific results. And so we've been working on this site. This debuted in November 2017. And at this point, we have more than 275 contributors and more than 525 articles. We publish a monthly digest that just provides updates on the content of the site, highlighting new things. And we have more than 650 subscribers to that mailing list. You're welcome to join us. If you're not familiar with this site, you can go to the site, take a look around. This is our current blog roll. And there's up at the top, there's a place to subscribe to the digest, and you can see what you have. And we would really appreciate contributions to the site. This is a community-driven site, and we really want to hear what resources people are finding useful for their scientific software development and to share them with others. And we've tried to make this easy. The site is backed with GitHub, and it's as simple as a pull request. Well, we can walk you through the first one, and after that, it should be pretty easy to be able to do it on your own if you want to make additional contributions. And so with this, I want to stop again and see if there are any new questions that have arisen about this work on methodologies.
No new questions here, David.
All right. And so the last area of that I want to talk about is how we disseminate knowledge, how we reach out to the larger community. And some of these things you may have heard of, you may have participated in. I hope some of these things are not entirely new to you, but if they are, please, be aware. We're going to try to, as I'll say later, we're going to try to continue some of these things in other forms as we go ahead after ECP ends. And we hope that you will avail yourselves of the opportunity to engage with us. And as I said before, with this outreach component of the IDEAS project, we really here in particular tried to design things in a way that supports not just the ECP community, but really make these things available to the community at large. And so one of the things that we actually have done in this space is the BSSW Fellowship Program. This has been running since 2018. And we are in the process. We've had a good crop of applications for the 2024 class. We're going through those and making our selections. And in a couple of months, we ought to be able to announce the 2024 class of BSSW Fellows. This has really been an important thing for us to help grow the community that's interested in scientific software and to identify new leaders and help them engage with the DOE and lately also the NSF communities. And that's something I also want to point out, since this has been supported by the ECP since 2018, but since 2021, the National Science Foundation has joined us in supporting fellows as part of the BSSW Fellowship. So this is really, this is an example where another agency in the US government has said, yes, I like this idea. I'm going to invest money in it too. I think it's a good idea. And so we've been building this out, and this has been really nice. You've heard webinars from these folks, blog articles, you've maybe attended tutorials at conferences or other things that these folks have done. And we've been really pleased to work with these folks and help grow the community in this way. We've also given a lot of tutorials over time since 2016, which is back in the IDEAS Classic days. We started doing some tutorials, and we've done more than 30 since then. These are all archived on a site that I've listed here, and you can go and find all the slides and some of the recordings, especially more recently. We cover a variety of topics, and it may vary depending on how long a given tutorial is, how much we can cover. But we're talking about software design, agile methodologies, Git workflows, reproducibility, testing, refactoring, and a lot of other things. We've tried to focus these tutorials on aspects of scientific software development where it's hard to find training resources or tutorials, educational resources in the larger community. So we're not going to be talking so much about Git per se, because lots of people have done Git tutorials and things like that. But we are going to talk about, say, Git workflows that will help scientific teams, scientific software teams work together better. We give a lot of these at large-scale conferences like supercomputing. We have one coming up next week, actually on Sunday. We're often at ISC. We've been giving a related track in the Argonne training program for extreme scale computing for many years. And these are ways, by making these more broadly available. We also do these at the ECP annual meeting and at other things, but these are ways that we help get exposure out to the broader community. And we really love to engage with a broad audience at a place like supercomputing, because we get feedback from all kinds of different people about the topics that we're covering and about their experience as well. And so this is, we really like to give interactive kind of tutorials, and we appreciate hearing from the participants as to their experiences. The webinar series that you're attending right now may be something you've attended in the past. This is actually the 80th instance of this webinar series. This is another thing that started towards the end of the IDEAS Classic period, but we've continued it on. It's lately led by Osni Marquez, as introduced today's session. We've had more than 12,000 registrations and more than 5,300 actual attendees. We usually find that 40 to 50% of the people who register actually attend, but we make sure that when we archive the webinars, so we put the recording and the slides and the Q&A online for folks. They can go back and review these things, and everybody who registers gets a note when that material is available, so they go back if they had a conflict and couldn't actually make the webinar or things like that. They can go back and review it. And this is another way that we've been able to include other voices. So this is not just the IDEAS team. In fact, it's rarely the IDEAS team that's talking at these webinars. This is people from the larger community, and we've, you can see here 12,000 registrations over the years. We've been able to reach also a much larger community, and we're very pleased about that. Performance portability has been a really important thing to the Exascale Computing Project because we have several different architectures, and there's been a lot of concern about how much code might be necessary to support these different architectures while providing the necessary performance and capability. And so Anshu Dubey led a series of panel discussions that were mostly internal to the ECP community while they were happening, but had several products outside after the fact, kind of summarizing the findings. There's a paper in IEEE Computing and Science and Engineering, and there were a couple of mini symposia where the sort of outcomes and takeaway messages were shared. And you can find all the presentations from this mini symposia, for example, at this link. Also, when COVID happened, everybody went home and had to work remotely. Some people have been doing this for a while, but we thought it would be useful to have opportunities to discuss this. So Elaine Rayborn started this panel discussion series, and it's been mostly a quarterly series. And so you can go find the archives for that at this URL if you want to go back and take a look at some of these things. But Elaine also wrote a paper for the SC20 State of the Practice about this series if you're interested in learning more. And then something that we do a lot of people, different people are involved in this, is to organize, technical sessions and birds of a feathers and things like that at various conferences. So the idea here is to create opportunities for folks to talk about software development, productivity, sustainability, trustworthiness, in settings where most of the conversation tends to focus on the science outputs. So we want to provide opportunities to focus more on the software and those kinds of experiences. And to do that, we'll organize mini symposia or birds of a feather session or poster sessions at conferences where this is a possibility. So if you're at all familiar with SciAm, most of the SciAm conferences are kind of crowdsourced. They're organized around concepts of mini symposia, which you can propose. So we'll get together usually with people outside of IDEAS, because it gives us a broader perspective on things, and we'll put together a mini symposium, many times multiple mini symposia, and we'll have those also thematic poster groups, which are really quite fun. When they happen, you get a whole bunch of people together with posters on, basically software related topics, and you get to see a lot of different things, even more than you can do with a mini symposia. So they're a lot of fun. If you want to learn more about some of these experiences, an example is a blog article that we wrote based on what we did in SciAm 2021, SciAm CSE 21. And then I mentioned BOSS sessions, birds of a feather session. These are things at meetings. Supercomputing and ISC are particularly known for having these. Some other meetings have these. These are more informal sessions, not papers or anything like that, but more informal sessions to get communities of people together. And since 2015, actually, we've been organizing a BOF. The original, well, this is the title has changed over time, but it's something like software engineering in computational science and engineering, right? And so we're talking once again about the software and the people behind it. And there's a link here to find out more about the series and the archives of the notes of those discussions and things like that. And if you're attending Supercomputing 1 week from today, Wednesday evening, we will have the next edition of this BOF. And so I hope we will see you there. And we've also organized workshops on our own. This is a standalone workshop series that Mike Haru started. He happens to live in a place called Collegeville, or well, work in a place called Collegeville. And that's the source of the name of the conference. And this has been a really nice venue to talk, focus on different topics in scientific software as well. And there's a blog article related to some of this that captures the discussions of one of the Collegeville workshops. And these are just examples. And so, you know, the idea here is that we're trying to get people together and provide opportunities to talk about the software in venues where maybe the science tends to dominate things. And all this is a part of our efforts, overarching efforts to promote culture change. So in all of the work that we've done from beginning to end, IDEAS tries to promote a change in culture around scientific software. So we're trying to make sure that the people who are contributing to the software, maybe people who are more focused on software than research, we might call them RSEs today, research software engineers, are recognized and valued for their contributions, even if they're not leading papers and leading proposals and things like that. We think it's really important that these people who are bringing really important capabilities and knowledge to the development and maintenance of the research software have the recognition that they deserve. And likewise, we want to ensure that the software itself is recognized as a first-class product of the research. So not some afterthought, not just a means to an end to get the science done, but really we want to encourage people to think about the stewardship of the software itself as a tool that needs to be honed and maintained in order to continue helping produce the important science that you're doing. So we do this through engagement with sponsors. We've been talking to them over a long period of time, and I think we've had some impact in their thinking and some of the things that they're doing. We've been working with and supporting this growing community of research software engineers. USRSE is kind of the de facto professional society for research software engineers in the United States. Many of the IDEAS team members are also part of USRSE and part of the leadership of USRSE. This has been a very active engagement that we hope to make stronger in the future, as I'll talk about. And then recently, the Exascale Computing Project launched this broadening participation initiative with the idea of trying to expand the workforce in high-performance computing, noting that we're having challenges recruiting people, and also that the people that we have are not as diverse as we would like that group to be. And as part of that, within the IDEAS project, we launched the HPC Workforce Development and Retention Action Group, which is led by Suzanne Peretti-Kuhn. They have a website and a webinar series, and they've been talking about things that are important, particularly from the diversity, equity, inclusion, and accessibility standpoint, things like ally skills and diversification and mentoring and other sorts of things in this space. And so I would say IDEAS has had some impact over the years. These are some things that have come out of a recent survey. We haven't finished the analysis of this, but this is sort of feedback that we've gotten from the community in its early form. That feedback underscores the IDEAS role in enhancing software quality and promoting best practices and expanding awareness of the importance of software and software development. And also by curating best practices for software development, we've empowered teams to take these practices and implement them into their workflows and increase cross-project collaboration. And we've had community members asking for additional resources we haven't had the time to actually put together yet, but we hope to do more of that in the future. Software communities that I talked about in the beginning have proven to be a source of inspiration for building shared foundations for software ecosystems, while respecting that there are these individual teams that are participating and they need to have the appropriate degree of autonomy. And through our outreach activities, we've provided ways to enable not just the IDEAS team, not just the ECP, but many members of the community to share their knowledge and experience with the larger community. And so we would hold up IDEAS-ECP as a potential model for other multi-institutional software ecosystem projects to think about. We think there's a lot that we have to offer in the approach that we've taken. Moving forward, we haven't done everything, not by any means. We think we've had an important impact, but there are at least a couple really important elements that I want to point out that we think are necessary for continued growth in this space in the future. One is an increasing focus on what we call the science of research software. This is applying the scientific method to better understand how we develop and use scientific software. We need to pull in not just software engineering experts, but also, cognitive and social science and hard science experts to do this kind of work. If you want to learn more about this, Mike Carew, who kind of originated this term, wrote a paper in Computing and Science and Engineering a couple of years ago, just last year, I think, which talks about this, the term research software science. And a couple of years ago, the Department of Energy asked us to organize a workshop, which is in DOE, this is a basic research needs workshop, which is often a prelude to including these kind of concepts that come out of the workshop into funding opportunities down the road. And that workshop was on the science of scientific software development and use. And the report from that is also available if you're interested in learning more about some of the things that we think are important in this space going forward. And the other thing that is really important is this attitude, this culture change about making scientific software productivity, sustainability, and trustworthiness, not just nice to have aspects of your project, but must have projects. There's certainly people out there who are already there. They're already in the must-have space. These are the innovators and the early adopters. But I think you'll probably recognize that there's still a lot of people out there who really prioritize the scientific results, and oftentimes the sponsors help with this to make the scientific results more important than what would be beneficial investments in the software that is behind them. And so these are things, two particular things that we really think need to be carried forward. And so the IDEAS project or this incarnation of the IDEAS project will be ending in just a month and a half. And so we're not going to be able to carry this forward on our own. And so I'm going to spend a couple of slides talking about what might be coming down the pike. But before I do that, I want to take a quick stop to see if there are any new questions that have come up.
No, David, all good.
All right. So what's next? As I said, ECP is ending December 31st, 2023, and the IDEAS project ends with it. I'll note that of course, is only the IDEAS ECP project, so Watersheds continues. And if that's an area of interest, I encourage you to reach out to David Moulton from Los Alamos and talk to him a little more. As I mentioned, I'm very happy to announce that we have continued standalone funding for the BSSW fellowship, at least for the 2024 class. That's thanks to Oscar and also NNSA, which is the weapons lab part of DOE, and the National Science Foundation continuing their support. So we're very pleased about that, but we have work to do to keep that going. And then a big thing that's coming down the pike is the Next Generation Scientific Software Technologies Initiative also from DOE Oscar, which has the really pronounceable acronym NGSST. This is a developing effort to help address some of the scientific software stewardship needs in the Oscar software ecosystem. So the focus is different than ECP and IDEAS-ECP, but I think you'll see some of the ideas influence in the work that's been planned. And, you know, in order to keep some of these things that we've been doing in IDEAS going, we're also going to need to look for more input and engagement from the community to keep these things going. So first of all, NGSST, a few months ago, there's 7 teams were invited to submit proposals for an interlocking set of activities that would form this thing we're calling the Scientific Software Stewardship Consortium, S3C. And so they're all meant to work together. And the focus in this effort is to address what we're calling the Oscar scientific software community. That includes the Exascale ECP software technologies projects, the co-design libraries that have been produced, and some other Oscar supported projects. So if you look, this is a new diagram. This is blue instead of green, and you can see these concentric circles of communities. And I've tried to sort of, not to scale, but I've tried to overlay the ECP software ecosystem. So there's overlap with all parts of the ECP overlaps with these different areas that we're now thinking about under NGSST. And so you can see that not all of ECP software is going to be supported by NGSST. And you can see that there's also a lot of other opportunities if we could get additional funding going for these things. With the funding that's currently available, we're only going to be able to support a subset of the projects in this Oscar software community. So, you know, there's going to be some funding available, but only for a limited set of projects. The hope is that most of these 7 projects will be able to get started in January. So there's a certain degree of continuity for the people who are involved there. And just to connect up with what's been going on in IDEAS, we see some of these activities. So in terms of the software communities, certainly the E4S stack is a significant component of one of the 7 projects. Many of the other 7 projects are focused on various software communities. I don't have access. I haven't seen all the proposals, so I don't know if they're going to pursue these SDK concepts that we've been talking about to really get things more tightly connected, but they're certainly organized around particular communities. In terms of incubating and curating methodologies, there's going to be a focus on software quality assurance and probably other areas. We're hoping to continue the bssw.io resource portal. And in the disseminating knowledge outreach areas, we want to continue this webinar series. We're planning to continue the Better Scientific Software tutorials in another form, and we expect to have additional training activities coming in from the other 6 organizations. And so this will be maybe a larger set of opportunities for training that people will have access to. And then in terms of the culture change, we're planning to continue activities of the Workforce Development and Retention Action Group. And we're also going to be working to build a community practice for RSEs in the DOE National Laboratories. So this is not everything that IDEAS has done, but you can see that there are some significant things that we hope to be able to carry on if the NGSST stuff works out as we hope, as we've proposed. But a really important message that I want to leave you with is that we really need you to get involved in this too. So IDEAS or NGSST can't do this alone. If you're a developer or a user of scientific software or a manager of people who are in that role, you have a role to play in making scientific software better. So we would encourage you to be thoughtful about the stewardship of your own software. It's think about it as an investment, not a tax, and work with your team to learn about and implement better software development practices. And I encourage you to review this PSIP process that I talked about. I think it's a really useful, simple, straightforward way to try to build up your software practices. It's really valuable to share your knowledge and experience with others. IDEAS has been providing some venues to do that, and we hope to continue them, as I said, but we really need for more folks from the community to help us by contributing to bssw.io, to offering to do webinars in this series and things like that. And really, there are a lot of communities out there who are concerned about various aspects of scientific software, research software. It goes by different names. And we encourage you to find the communities that are most relevant for your work and engage with them, but do something in this space. And also, as you're doing all this, talk with your sponsors about what's important and about software stewardship, what you're doing in this space, the benefits you're seeing, and how your sponsors can help you do a better job with that. And so I want to end with this message that we give all the time in our tutorials, that science through computing is at best as credible as the software that produces it. So we really, anywhere you're working in the scientific software space, anybody that thinks the science is important should hopefully think that the software behind it is important as well. So I want to acknowledge the IDEAS-ECP team, who've been a great collection of people to work with, and I hope after this presentation that they'll still continue to work with me for the remaining few weeks of ECP. And I want to thank everybody. I also want to thank the ECP itself, all the people involved in it, and the leadership who recognize the importance of a really strong initiative in software productivity and sustainability as part of the ECP. And with that, I'm going to go back to this call for action and take any final questions that may have arisen.
Hi, David. Thank you. Yes, there were a couple of questions that I think I missed some slides back for a few seconds. Actually, we asked if there were questions, and then 2 questions came in. So the first one that I think you have already kind of addressed by Alfred Tang is DOE committed to funding ECP in the foreseeable future?
So there is no follow-on to ECP. There may or may not be other large-scale initiatives, but they won't be ECP per se. If you follow the news, you may have seen a lot of discussion about artificial intelligence, and there's potentially a significant, DOE might have a significant involvement in, AI for science types of things. That may be a big initiative, but it's not there yet. And there are other things. NGSST is what I would say is a modest investment in the software stewardship in particular. But a lot of the ECP projects are going to have to sort of be creative and find new sources to support their continued work.
Another question here, David. Could you say a little more about the IDEAS community? How many, who, and any trends you have captured?
Well, so the IDEAS community, I would say in the small, is the folks who've been involved in the project. And so this is, sort of the most recent. We've had a lot of people come through over the last 5 or 6 years that we've been active. And these people bring a lot of different experiences and interests to the IDEAS community. And you've heard about a lot of the things that have come out of that. But I do want to emphasize that a lot of what ECP is about has been serving a larger community. So really, we're interested in the much broader community of scientific software development that's not even limited to DOE. There's a huge space out there. We're increasingly reliant on software for the conduct of any kind of science, and this is really important. And we're trying to engage with a much larger group who's been to further this overall goal of improving scientific software. And there's a lot of other folks out there. So we have our project has had a lot of interactions with a lot of other projects and groups around the world, and it's been really satisfying. And so I don't want to pick on anything in any projects or people in particular, but there's lots of folks out there to engage with on these topics.
So I'd like to invite I think we have a few minutes here. I'd like to invite the participants. If there are any questions to participants, can unmute themselves and ask directly to David if there's any other Questions?
I see that I'm striped. I should close my blinds.
Any additional questions for David?
Hi, David, this is Elaine. I'm just,
Hey, Elaine.
hey, I'm also wondering about the BSSW community, actually. I know that that's quite a bit larger, and so I'm wondering if you want to say a little bit just about that, because there's you put a lot of effort into that.
Yeah, so this is the bssw.io resource site. And so BSSW, Better Scientific Software, is kind of a brand that we've used to identify a number of things, but the most prominent, I think, is the resource site. As I mentioned, we're hoping to continue that under NGSST. The funding that we can allocate to that for our own piece of it is quite modest, much less than in IDEAS. So we're really going to be relying even more on community contributions to keep that site interested and going. So we have a blog stream. We have what we call curated content, which are just pointers to resources that are out there. And we have this event stream, and we're open to contributions from the community, and we'd love to have you contribute.
Any further questions? All right, David. Thank you very much.
All right, thanks everybody.